nice. Remember that N number is invisible. Usually. This time it actually wasn't. They gave it to you in this chart, which is nice. If they give it to you, that'd be awesome, because then you really don't have to think about it. I don't know if they will or not. I'd bake on it being invisible. You just look at the charge. If it's a 2+ charge, that means it lost 2 electrons. You get a big negative G number. Remember, that means it's spontaneous. That also means that K is going to be greater than 1. For letter F, there's lots of words, but you kind of need all of those words, because in those words, it tells you that the concentrations of the zinc is 1 and the concentration of the copper is 1. So K is going to be products over reactants. Those solids don't go in there. That is, we're not using them. It's going to be 1/1. But then it says, let's change the copper to 2. I know it gives you a volume, but that doesn't matter. Milliliters aren't in this equation, so that's extra information. Products over reactants, so half is smaller than 1, and when Q is smaller than K, it shifts right. That's a forward reaction. In Voltaic cells, forward reactions produce electricity, so it increases our electricity for that. EMF is the same thing as E cell, is voltage, is all the same. Letter G was new to me, but this is a pattern I'm seeing. They keep asking like random things and how it affects it, but they're not in the math. So they're like trick questions. So for letter G, I haven't seen this one before, but it's a good one. If I change the mass of the electron, how would it affect anything? And grams isn't anything that in our math equations, right? It's not in our knife, it's not in our E cell, it's not in any of those. So it would have no effect. Okay, that's kind of a new trend I'm seeing, so good to bring that up. Today we just have a small little lesson for you. We only have one more thing to learn. And then after that I have a little thing for you to get ready for a quiz we're going to have on Thursday. So quiz will be Thursday. Lab will be Monday, because Drew and I have to make the solution, which we'll do tomorrow. And we'll have it set up for Monday. Okay, so can you just talk with your battle buddy about G especially, like why it doesn't have to do with anything, and then get out your notes. Ready to go. We are going to start here in the notes, which is like toward the back. So you're going to have to this is on the bottom of the page. Help your battle buddy out once you find it so they can find it. There's kind of a lot of pictures that look like this. Yeah. You found it? Can you help the person next to you? We're all in this together. We're going to help each other out. Okay, vocabularies. A Voltaic cell is the one that produces electricity spontaneously. I do not have to do anything. The electrons are like, come on, little guys, and they just kind of flow automatically, right? That's called spontaneous. Delta G is negative. An electrolytic cell is the reverse of that. So the forward reaction is spontaneous. Come on, little guys, all by themselves. The reverse reaction is non-spontaneous. Way back the first day, I'm like, the words I use is driving forces for non-spontaneous. Those are real words. A driving force for a non-spontaneous is electricity. So an electrolytic cell is when I do the reverse non-spontaneous reaction, but instead of a voltmeter, this would be a battery, or this would be something where I plugged it in. I can force a non-spontaneous reaction by plugging it in. We then call it, not a Voltaic cell, we call it an electrolytic cell. In real life, you might have heard of something called chrome plating. Chrome plating is to like make something really shiny and silver. So I think it's on like fancy cars. But chrome plating is, and I'm telling you this specifically because this is the question is going to be. It's when you take chromium metal and you bond it to a cheaper metal. So it makes it like super shiny and pretty. And it's an electrolytic cell. They plug it in and chromium grows on it. So just like this, we're growing copper on my copper thing, but it's doing it spontaneously. Chromium grows chromium on a piece of metal non-spontaneously by plugging it in. So the way you know it's an electrolytic cell, because it doesn't say a voltmeter, it says battery. That's for an electrolytic cell only. Change it out to a B for battery. This is a non-spontaneous reaction, which is the reverse of a Voltaic cell. If you do it backward, it's not going to happen automatically anymore. Okay, so our delta G for these are not negative, they're going to be positive delta G now. Lies left, that I can plug it in and get it to go. Plug it in can be a battery. Okay, my E cell is going to be negative, which I think it is. Yep, my E cell is negative because I'm doing flip that I reverse the reaction. Okay, the math for these are just conversions. Weird enough, it's just a conversion. So it's like thinking back to baby chem, grams to moles, moles to, okay, so we're going to play that game. So when the music starts, please just talk about the difference between electrolytic and voltaic, and then we're going to do 2 sample questions. Ready, go. We are here on number 15. Two things we wrote down on our charty chart notes from yesterday. Let's just write them on the top here so they're a little handy. A coulomb is an amp times a second. And 1 mole of electrons has 96,485 coulombs. That's called Faraday's constant, and we were using it in -9. Today we're going to use it like a conversion factor, okay? Those are things you don't need to memorize. They're all in your equation sheet that you'll always have. So the question says, calculate the number of grams of aluminum. So our question mark, what we're trying to solve for is grams. Produced in 1 hour by the electrolysis, that's the vocab word for today, the backward reaction, of molten just means melted, aluminum chloride if the current is 10 amps. So things I know, I have my amps, 10. I also have my seconds because 1 hour is 60 times 60 is going to be 3,600 seconds. Okay? So I can figure out coulombs, and then I'm going to show you how to go from coulombs to grams. Okay? So let's start with our coulombs. Our coulombs equals our amps times our seconds. So that's just a scoochie forward one situation. Oops, coulombs. Okay, now watch this. I'm going to play a conversion game. Always start with what you know over 1 times in a line. Coulombs on top means coulombs on bottom. The conversion factor I have is 96,485 coulombs are in 1 mole of electrons. Moles of electrons on top means moles of electrons on bottom. The moles of electrons are the invisible number. That's that N number that you kind of have to just figure out from the charge. So we're going to look back in the words, and what I'm using is aluminum. So maybe you know the charge of aluminum. Maybe you have to look it up in your gold packet, but tell somebody next to you what the charge of aluminum is and therefore how many electrons are being lost. Ready, set, go. Yeah, so it's 3 plus, so that means that it lost 3 moles of electrons, that invisible number. For every 1 mole of aluminum, Moles of aluminum on top means moles of aluminum on bottom. We can convert from moles to grams by using something called molar mass. The babies learned this yesterday. Does anybody know the molar mass of aluminum offhand? Yeah, 26.9. That is okay, so go ahead and push your buttons because it's not about pushing your buttons, it's about being active in your learning. All you get is a periodic table. Equation. Yeah, you have one right next to you, though. You don't. Okay, with your battle buddy, you're going to do number 16. Now, this is backward. This time, you're solving for seconds. How many seconds is needed to deposit in your given grams? It's chromium, not aluminum, so your charge is something you have to look at, but you still have amps. So with your battle buddy, now go backward. Start with your grams and get to seconds. Ready? Go. Go into your AP chemistry class. Your college board class. They made you make like a difficult password, so it's like that. Your username is like the long school. It's the name of the number. That's what's it's just not true. Yeah, I mean mine too. I mean, what you saying? Yeah, you have one assignment. I just want you to open it and get there so we can do the first one together. Okay, what I have for you today is 10 questions. Anytime we do things from the College Board, our goal is always at 50%. So your goal is one hand. The average, it gives me stats, so I just happen to know. The average was 8, and several people got 10. So this is good. What you're doing is you are practicing together with your battle buddy, reading the words of AP words. Reading the words is like the hardest part. And it has to do with the stuff that is in your notes. So I'd like get everything out, all the little sheets that we made, the charty chart, so you have it next to you. And there's 10 questions you're going to go through. So let's do the first one together, though, because I'm going to kind of talk out loud how I do these. Now, you might be better at reading than I am, but this is how I think through all of these words and reading. So it says when hydrogen and oxygen are mixed together in a rigid reaction vessel at 25 degrees Celsius, no reaction occurs. When the mixture is sparked, however, the gases react vigorously according to the equation above, releasing heat. So the words releasing heat means it's exothermic. That means my delta H is negative, okay? And I know that because I have a chart with H's and S's on it. If I can't remember, it's like a half sheet. Which of the following statements correctly explains why? So the question is, why is the spark needed to get it to go? So letter A, the reaction is not thermodynamically favorable at 25 degrees Celsius cannot be true because it went. Okay. Delta H for the reaction is positive, not true because it released heat. So I eliminated A and B without really even thinking too much. Delta S for the reaction has a large negative value. So I'm looking back here and I have gas, gas, gas. Okay, so the kids are partying. I have 3 moles to 2 moles. So it does go down, but I wouldn't call that large, right? You're still having a party. It's not like it's going from a gas to a solid where you have to put your seatbelt on. So I'm going to say probably not C, but maybe I'm just going to keep it just in case. And D says the reaction has a large activation energy. Do you remember what activation energy is? It's that hump, right? And it's like how much energy they need in order to react. So all the words that say it needed a spark to react makes me think that it needed like a shove up the activation energy hill. All of that, I'm just thinking, because I know it's not A and B for sure. I'm pretty sure it's not C because it's not large negative value. So I'm going to guess D. Okay, which is right. So I just did one with you. You're going to, the idea is to talk it out with your band buddy, like learning through talking. It won't give you results until after you're done, and you have to refresh the page and then go back and look at the ones you got wrong and the ones you got right and everything else. Okay? Ready? Set. Well, we don't want to.